Hello YouTube, this is my replication of the Kromrey G-Field generator, and I'm just going to go through and give you a quick run through of my design, where I went wrong with my design that causes it to not work the way it should, and how you can make a better model than I did. So first of all, let me start off with what I'm using to power it. I have three 6-volt batteries hooked up here in series. This is an electric motor from a electric scooter. And it's a DC permanent magnet motor, so I added some magnet to the same polarity as the ones on the inside, on the outside, just to kind of increase the efficiency and the torque. Because this thing needs quite a bit of torque to get going, unlike the Eklund type generator. If you haven't looked that up, that's Eklin. He also has a very similar design to the one that that Bedini modified from Kromrey. The original Kromrey patent looks nothing like either of them. So Bedini really did kind of invent this if he did design it himself. And it's a brilliant machine. I mean, there are some keys about this machine that are imperative. First of all, these need to be wound in opposite directions, so that if I ran power through them, like here I have these hooked up to my battery, if I turn that switch on, this will turn into an electromagnet with north and south here. But since these are wound the opposite directions, if I hook these up together as they're supposed to be hooked up, then this would be north and this would be south. And this would be north and this would be south. And that's very important because the magnets are set up that way, north-south, north-south. And that brings up one of my design flaws, because the way this machine works is it pumps the block wall, which is the little space in between the north and the south pole. And it pumps this little space for energy. And what I did in my design was I electrically connected, using silver solder, this iron bar to my brass armature here. And I connected this this iron bar to this aluminum piece here. And that conductive loop that's lost here, because the aluminum is touching the brass here as well, that causes an inoperational unit, because the block walls lose their conductive, I guess you could call it a conductive property. It needs to be conductively isolated, and here I have it so it is not conductively isolated. So that's where I think the main problem with the design I have is. I'm going to replace this aluminum block here, which I basically have connected to wood down there, just for support. I'm going to replace it with more wood. And these magnets here, I use neodymium magnets. They are 24-pound pull force. They're pretty strong, but they are coated with rubber. That's what you see here. And you can see that they've been hitting the iron bars because the rubber is kind of coming off of the magnets. And the reason for that is because this is loose. My silver solder came loose. It wasn't strong enough to hold it. I need to take it off the brass armature anyways to remove that conductive loop, but it's loose and it doesn't perfectly line up with this one as it should. As these are going through, they should line up perfectly with this, but they really don't. They're off because this is loose. So I need to fix that. My machine's running really loud right now because this oscillates and starts hitting the ends of these iron pieces, and that's really noisy. So this unit is inoperational right now. I run it up, and you would think that even though the block walls are, the conductive loop is broken in the block walls, you would think that I would at least get some output, because I have, 240 winds of coil between the two of these bars, and I have 4 24-pound neodymium magnets coming through at an RPM of around 1,000 RPM, and my output is nothing. I'm not getting any output, and I'm testing that through this AC to DC rectifier, and I have that hooked up to a little DC motor just to see what kind of output I'm getting in a general sense. I broke my voltmeter by checking the continuity of my coils. I accidentally had my coils hooked up to the batteries, and I checked the continuity between positive and negative pole here, broke my amp meter, so I can't show you guys what my amp meter shows, but it shows basically that nothing's coming out of these coils. And conventional physics would say that if you have an iron bar and you have some magnets, and you attach the magnets to the iron bar, and then you take the magnets off the iron bar, then you would have two discharges. And JB says this as well. You'd have a perfect sine wave, two sets of discharges when the magnet hits the bar and when the magnet leaves the bar. And that's because an electrical discharge happens when the magnetic flux changes. So when there's a change in magnetic flux, there's a discharge through the system. So I spin this thing up to 1,000 RPM, and there's no electricity coming out of it at all, which I find kind of anomalous. It just kind of shows me that I need to keep tinkering with it, get it right in order for the proper phenomenon to exhibit themselves. And so what I believe this machine will do when I fix these conductivity issues, maybe a few other issues down the road, is basically it should give off cold electricity as opposed to hot electricity. Now some of you, in fact most of you, are probably like, what the hell is cold electricity? And first of all, some of you are probably like, this looks nothing like the Kromrey G field. He has the iron bars as the, those are connected to the armature, and he has the magnets as the stator. And that is the way that JB did one of his. I've seen other models that JB has done like this. The reason JB does, and when I say JB, I'm referring to John Bedini, by the way. When he designed his magnets as the stator, what he was doing is increasing the amount of magnets he used without lowering the efficiency. Because the more magnets you put on the armature, the more rotational force is needed, the less efficient it is. Because the power of this device is directly related to the power of your magnets. The more powerful magnets you have, the more power you should get out from this device. And so if I could redo this whole thing, what I would do is I would thread these aluminum pieces all the way down so that I can move these aluminum blocks in and out so that I could add more or less magnets. I would make the magnets the stator instead of the rotor, and I would electrically isolate these iron bars from the armature if I could do it again. But since I have this device, and this was kind of a proof of concept thing, that's why I did it differently, because I figured if that way works, then this way must also. It's kind of the opposite idea. So here I have my coils wound correctly. I have this side of the coil connected to this side of the coil, and I have my output on this side, and this side coming to my AC to DC rectifier here, and that, little connection issue, and that is hooked up to this little DC motor right here. And there you go, you see that. Okay, so I'm going to run this up for you guys. It's going to be really loud, and I don't expect anything to come out of it because that's what has been happening lately, because of my conductivity issues. So here I go. So, first of all, there you see it touching the magnet. It hits that magnet. The pull force is pretty strong. I should be getting current out, but I'm not. And I gotta fix the conductivity issues. So that's my Kromrey replication. Like I said, when I had the coils wound, well, actually I don't know if I've said this. When I had the coils wound the same direction, which is I didn't wind them the opposite directions, I found that I did get output, AC output, and it was hot, and I was able to run my solid-state Tesla coil on it. But since I've fixed the coils the way they should be wound, I have not gotten any output, which is strange, and really it defies physics in many ways, because I've checked the continuity of my coils. they're all connected, right? I should be getting power out regardless, because I'm having relative magnetic flux differences between the zero state it's in now and the activated state it is in when the magnets come through. That should create a difference in electrical potential, and I should see output, but I'm not, so that kind of tells me something anomalous is going on here, unless I'm misunderstanding the phenomenon, and I'm going to continue to work on this device, and I'll keep you guys updated, but I just thought I'd show you so far what's going on with this. So that's my Kromrey, and if you guys have any advice or tips or anything like that, just leave them in the comments section. Thanks for watching.